Good afternoon, grade 12s, and welcome to this afternoon's broadcast of the mathematical literacy lesson on data handling. If you have any questions during the broadcast, you can WhatsApp to the number 083 792 1239. My name is Mrs. van Graan, and I'm a teacher at CBC St. John's in Parklands. All right, so let's start with today's lesson. And today's lesson will be on data handling. So what is it, grade 12s, that you can actually expect when you need to answer questions on this? So before we are actually going to continue with questions, there's a bit of theory that I would like to cover with you before we go to the questions. So the first thing, what you can expect is, how do we collect data? Okay, so we can either collect data in the form of a survey or a questionnaire. I'm quite sure you know what that is. A questionnaire is where you literally draw up a questionnaire and you ask questions to people, you ask them to fill it in, and then you can collect data according to what they answered the questions, and then you can display those the answers that you received. You could also collect data with observation. Now, if you don't know what observation is literally when people, I'm quite sure you see people sit next to the road on a chair and they have a clipboard on their lap, and they literally count the cars that are going to pass them, or they count the amount of cars parked in a car park because they want to do a survey through observation to see if they must enlarge the car park or if they must rebuild the roads. And then an interview. An interview is literally where you sit, you also draw up a set of questions, but you interview someone. So in the questionnaire, you allow the person to fill it in themselves. In an interview, you ask the questions. So that is more or less how we collect data. The means of. Now, the next thing that we are going to do is we are going to classify the data that you've collected. All right? So every year in the matric exam paper, they have some or other question regarding this. So they will give you a set of data and they will say, classify the following data. So we classify the data into two groups. First of all, we have categorical data and we have numerical data. So for you to answer these questions, you need to know the difference between categorical and numerical. All right, so categorical is where you group things, so it's grouped data. It is things like race or age groups or subjects. So as you can see, this is information that doesn't present itself in the form of numbers. So that is why they are categorized into different categories. So there's no numbers there. So if you take the subjects that you take at school and you are going to put them in certain categories, that's categorical data. Or certain subjects that they take at university or any of those. Different race, different age groups, they are all categorical. Then if we move to the other side of the page where they say numerical. So numerical, of course, will be numbers. All right, that's why it's called numerical. So first of all, we classify data. Data is either categorical or numerical. But under numerical, we also classify them again into discrete data or continuous data. So what is discrete data? Discrete data is countable. It's countable data and it must be whole numbers. Countable whole numbers, in other words, people, People will fall under this. Cars, if you count cars. If you count animals. All right? These are all discrete data. You can't get a half a person or a half a car or a half an animal. All right? So it is all whole numbers. In other words, they are countable. There are this amount of dogs in your house. There is this amount of people in the school, or that amount of cars parked in the car park. So they are all countable and they are all whole numbers. All right, so that is discrete data. So what is continuous data then? So continuous data is data that can be measured. So for continuous data, we measure. Data that can be measured. All right? So something like today's temperature, that is data that can be measured. Or your weight. All right? Or how tall are you? Those are all things that can be measured. So the temperature of today, according to the weather, they normally round the temperature and they say the temperature is 24 degrees. But it's not necessarily the correct temperature. Temperature can be 24.1, 24.5. It can be anything like that. If you look at your weight, so you will round your weight and say you weigh 55 kilograms. But if you get onto an electronic scale, it will maybe say 55.6 kilograms. Or how tall are you? You are not necessarily a 1.9 or 1.6, you're 1.65 or 1.66. So if you go to the shop and you buy tomatoes and you put 2 tomatoes in the bag and you go to the machine to get it weighed, you can't say 1 tomato will weigh 200 grams or 2 tomatoes will weigh 400 grams. So these continuous data is everything that we can measure. In other words, you will have a comma in it. It won't be whole numbers. It will be numbers with commas. That's why we say it is data that we can measure, where discrete data is whole numbers, because people and cars and animals are involved. So before we step off here, just want to classify again that we can classify data into categorical data and into numerical data. Categorical is where we divide them into different categories, all right? They are grouped, and they don't present themselves in numbers. Where we go over to the numerical data, so numerical data can be classified in discrete and continuous data. Discrete, where we can count them, whole numbers. Continuous, where we measure them, where we can weigh 55.6 kilos, so they will have commas. All right, so that is how we classify data. All right, so we're going to move along, and then we are going to move along to what we call measures of central tendency. Okay, now, not necessarily in a paper 1, but in a paper 2, they can ask the question and they can say, use the measures of central tendency and work out the following. And if you don't know what the measures of central tendency, what it is, then you don't have a clue how to answer the question. So grade 12s, it is important that you understand that measures of central tendency is mean, median, and mode. So their collective name is measures of central tendency. And mean, median, and mode is then that. So before we are going to continue, I want to recap that we make sure that we understand each concept. So mean. Mean is another word for average. And please, grade 12s, know both, because sometimes in an exam paper they ask, work out the mean. Sometimes they ask, work out the average. And if you don't know that it is the same meaning, then maybe you don't know how to answer it, and you are then going to lose 1 or 2 marks where you could get a 2 or 3 marks as well. So mean, average. How do I work out the average? I add up all the data that's been given to me, all the numbers. Let's take an example. Say your teacher wants to get the average of your class tests. Then if you are 30 children in the class, she will add up all your marks and she will divide it by the 30 learners in the class. And then she'll get the average, either the average mark or the average percentage, depends on what she added. Then we come to the median. So the median is the middle value of a data set. Now, if I say the middle value, it is very important, grade 12s, that when we work with the median, we organize the data from small to big, or the other way around. It doesn't matter if you order them from big to small, as long as they are ordered. So otherwise, if you then just scramble the data as you receive it, and it's not ordered, you will not find the middle value of the data set. And the last one in the measures of central tendency is the mode. Now, the mode is the number that occurs the most in a data set. So you can have more than one mode. In other words, you can have a number that occurs more than once. You can have we call it a bimodal. If you have 2 modes, you can even get 3, a trimodal. All right, so if you have 3 numbers that occurs the most, you can. So don't get upset or confused and think there's something wrong with the data set. It can happen. Okay, so measures of central tendency, mean, average, same thing, median, and mode. Okay, so before we continue, I want to do a little exercise with you, and that is to work out those 3 concepts. Okay, so if we're then going to do the following, I'm going to give you a data set, and I'm going to give it to you already ordered from small to large. So we also get uneven and even data sets. So let's start with uneven. I'm going to start with an uneven data set. So I'm going to give you the following data set. Let's just see if it is uneven. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, there is 11 numbers in the data set. So we are going to work out the mean. So we are first going to work out the mean. So remember what I said? To work out the mean, we are going to add up all those numbers. Please use your calculator to add them up. So you are literally going to take your calculator and you are going to say 4 plus 5 plus 10 plus 12 plus 15. You're going to add them all together. So when you add them all together, you will get 181. That is all of those numbers added together. Then we're going to divide it by 11. That is the total in the data set. And then I get that the answer is 16.45. So let's take it, 181, divide by 11, and the answer is 16.45, rounded to 2 decimal places. Mean or average. Then the next thing I'm going to work out is the median. Now the median is the middle value, and it is already organized for you. So I'm going to count 1, 2, 1, 2, 1, 1, 1, 1, 1, 1, and I see 18 is my median. Then mode. Mode is the one that occurs the most, and I have 2 numbers. There they are. There's 2 18s. So 18 is also my mode. So this is how I approach an uneven data set, meaning an uneven number. Then I am going to do an even set of data. All right? So we're going to go to even. Okay, let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers, even. All right? So what do? We are also going to work out the mean. So same procedure. Add up everything, 4 plus 5 plus 10 plus 12 plus 15, 18. You add them all up. If you add them all up, it's 189. I divided by 10. Why? 10 numbers in the data set. Then the answer is 18.9. Then I go to the median. All right, median is the middle value of the data set. So I am going to, and I see I have 2 middle values now. I have 4 on that side, 4 on this side, 2 middle values. So on an even data set, I will get to 2 middle values, 15 plus 18. I will divide them by 2, and I get that the answer is 16.5. So what we do, grade 12, is you say 15 plus 18 divided by 2, and you get the answer is 16.5. Then I need to work out the mode. Then I look at my data set and I see there's no number that occurs twice. So in other words, the answer in this case, grade 12, and I want to just make it clear, the answer is not 0, because 0 is a number and it can be the mode. So if there's no number that occurs more than once, then the answer will be no mode, but never 0. Only 0 if 0 appears more than once, because be careful, 0 can be a number. So if there's no mode, the answer is then no mode. All right, so this is even and uneven data sets, how to work out mean, median, and mode. And remember, grade 12s, we call them measures of central tendency. All right, then we continue with the theory. So we did measures of central tendency, mean, mode, and median. Now we come to what we call measures of spread. Now, the range is a measure of spread, okay? So what is range? Range, grade 12, so if I go to my previous uneven and I want to work out the range, then the range will be my highest number in the data set, my highest number minus my smallest number. So the range will be 28 minus 4, so the range is 24. This is a measure of spread. The highest number minus my lowest number. That is then 24. That is how we work out the range. Then another measure of spread is what we call interquartile range. But before we can go to work out interquartile range, I first would like to discuss quartiles with you before we go there. So if we then continue and we have an uneven data set again, and I give it to you as the following. Okay, let's just count to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Uneven. Okay, so we are going to do the following. We are going to work out the quartiles. So we get quartile 1, we get quartile 2, we get quartile 3. Quartile 2 is also called the median. So what is it that the median halves the data set. What does a quartile or quartiles do? They divide them in 4 equal parts. That's what they do. Where the median divide them in the middle, quartiles 4 equal parts. So if we're going to go and we are going to work out the quartiles of this data set, then we approach it the same as when we work out the median. So 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So 15 is the middle value. 15 is then quartile 2. 15 is also the median. So this will be 15. Then the data set is half now, exactly in the middle. Then this is upper or lower half, upper half. So what we need to do is we need to take this 50% and divide it in half, and we take this 50% and divide it in half. So what we're going to do, we have there two values, 5 is then quartile 1. So quartile 1 is 5. We take the next 50%, we divide it, 25 will be quartile number 3. What do we have now? 1, 2, 3, 4 equal parts. This is 4 equal parts, quartiles. All right, so Q3 is 25. Now, to go back to the measure of spread, we had to work out interquartile range. So interquartile range is Q3 minus Q1, which is then Q3, 25. Q1 we worked out as 5, so interquartile range is 20. This is when we have an uneven data set and we work out quartiles. Then I want to show you that we have, when we work out same quartiles, even data set. So then I am going to give you the following data set. Let's just count quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it's an even data set. So we are going to work out the median first. So we have 1, 2, 3, 1, 2, 3, 1, 2. And because it's an even data set, we will have 2 middle values. All right? So we're going to add them together. So to work out, we are again going to work out quartile 1, quartile 2, quartile 3. So quartile 2 will be 33 plus 34, and then we are going to divide them, 33 plus 34, we're going to divide it by 2, and we get that the answer is 33.5. All right, that is for Q2. Now, can you see what I've done? I've got an even data set. I've got 2 middle values. I halved my data set, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now I need to take this side of the data set and I need to divide it into 2 again. Remember, we are busy with quartiles. So I rule a line through my 2 middle values, and then I work with this side. So I get 1, 2, 1, 2, and then 30 will be my Q1. That is 30. And then I do exactly the same on this side, and I get that 45 is my quartile 3. So then my answer for quartile 3 is 45. And then I want to work out my interquartile range. So the formula for interquartile range is Q3 minus Q1. So I will say 45 minus 30, and my answer will be 15. And then I have my interquartile range. All right, so grade 12. So this is more or less theory about data, measures of central tendency, and measures of spread. And the categorical data, the numerical data, discrete and continuous. It's very important that before you attempt to answer any questions regarding data, that you actually know the theory. So theory for data must be studied, otherwise you won't be able to answer the questions. All right, so now we're going to move along. Seeing that we've dealt with all the theory more or less, we are going to continue and then discuss how it is that we can display it. So remember, grade 12s, what's important is if you ever decide to write a thesis or become your doctoral, you will need to draw up certain questionnaires. And if you draw up a questionnaire, what we said, how do we collect data? We must be able to display the data. And it is important to realize that your survey or your questionnaire, you need to ask the correct questions. So we are now going to go over to how do we present the data, and how can we, the data that we now collected, how can we present it? So one way of presenting data is to present data in tables. Okay, so this, I'm quite sure that you have this in front of you as well. So data can be presented in tables as the one that you see here. So we have the provinces, and then we have certain average percentages in income that they have. So data can be presented in tables. Then data can also be presented in what we call pie charts. All right, this is a pie chart, a bigger one and a smaller one. This is recycling materials that they have presented in pie charts, which is easily to see on the eye, the amount. Budgets is also a good thing that you can represent in a pie chart. Then we can represent data with a box and whisker plot. This, we'll get to it just now, but this is another method of presenting data, how to represent it. And then we come to single, multiple, and stacked bar graphs. So this is a single bar graph. What's important to remember about a single bar graph is that we have spaces in between. Then we come to double bar graphs, where we are going to compare different data sets. So this was energy sources in South Africa, 2001-2007. Seeing that we are here, just remember, sometimes you can't distinguish between the grays of bar graphs, that's double bar graphs. Just remember the one that at the top will be the one that appears first, and the second one will be the second bar graph. That's how we read them. And then we get what we call stack bar graphs at the bottom here. It's literally where they stack different bars on top of one another. And we must just remember, how do we read this? So the height of the bar will represent the total. There's quarter 1, 2, 3, and 4. So then that is the total sales of quarter 1. So the height of the bar will be the total. All right, so this is then how we can represent the data. So now we know how to collect them. We know the measures of central tendency and spread, and we know how we can represent them. So I think it is time for us to then move along to the questions. All right. So according to the questions that was handed out to you in the booklet that you received at school, I am at the question where it says tables, where it says use the table in Annexure A to answer the following questions. All right, so we are, if they say tables, we are at this question. The first question where I showed you, data can be presented in the following ways. So this is the table that is then connected to the question. So in this question, they say 1.1.1, arrange in descending order the average percentage incomes for 2015. All right, so there's a word there in the question that says descending order. So that is another thing that they do at data, is they talk about descending and ascending. And you can't raise your hand in a grade 12 exam or test and say, ma'am, what is it now, small to large or large to small? So if they say arrange in descending order, descending is from large to smallest. So the first thing, arrange the descending order average percentage income for 2015. So then we need to go over to the table that was provided to us. Average percentage income 2015, 2014. Then we eliminate the table on the right hand side because they specifically ask us to arrange the 2015 data. Okay, so let's then go and arrange the 2015 data. So 1.1.1 is the question, and if I look at the 2015 column, they said descending largest to small. So then we start with 37.1, it's 31.1, 30,2, 24.6, 24.3, 24, then 21.3, and 20.6, and 14.9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So you need to go grade 12s and make sure that you didn't miss a number. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers in the table, and we have 9 numbers on our paper. All right, so that's your way in which you're going to check to see if you didn't leave out a number. Then the next question that they ask, they say, list all provinces where the municipalities have an average percentage income greater than the mean percentage income for all the provinces during 2015. All right. So before you can list the provinces, you will need to go and work out the mean percentage. So how do we work out the mean? We're going to add everything up, and we're going to divide it by the amount that's there. And they are, again, busy with 2015. So grade 12s, they say 2015, then we work with the 2015 column and not the 2014. So the question, again, I'll read it. List all the provinces where the municipalities have an average percentage income greater than means more than the mean percentage. We don't have the mean, but we know how to work it out. So on the 2015 column, we're going to add all of those together. We're going to put them into our calculator. You are going to take your calculator, you're going to say 37.1 plus 31.1 plus 30.2. You are going to add them all up, and then you are going to arrive at an answer that gives you 228.1%. Then I'm going to divide it by 9. Why by 9? Because there's 9 provinces. So I'm going to say 228.1 divided by 9. Then the answer is 25.34%. Now I have the answer. They said, list all the provinces where the municipalities have an average percentage income greater than the mean. So this is the mean. You worked it out. Now I need to go and find which provinces is then greater than the mean. And then I go to my table and I see that KwaZulu-Natal is greater than, the Western Cape is, and Gauteng province is greater than the average mean. Then question 1.1.3. Use the information in the table to complete the bar graph on the grid provided on the answer sheet. All right, so they gave you, on your answer sheet, they gave you a bar graph. And they gave you information. So certain of these bars were omitted. So you can see this one wasn't filled in, that one wasn't filled in, as well as that one, and that one. They are all clear. There's nothing filled in. You can also see the first one is 2015 and then 2014. So you need to go to your table and look at the information that they give you and then see what is missing, and then you are going to fill it in. Please, grade 12s, use a ruler and make sure that when you fill this in, the scale is good, so you're not going to make a problem, and make sure that you fill it in so that you can get the 4 or 6 marks for this question. That is 1.1.3. All right. Then we are going to move along and we are going to get to study the pie chart. All right, so the next question is based on the pie chart that I just showed you earlier. So this pie chart below shows the total recycling and composting of material for 2015. So the next set of questions is then based on this pie chart. Okay, so let's, like I told you at the previous lesson, take a minute or two and have a look at what they are showing you. So a pie chart, normally they give it to you in percentages or in degrees. So 360 degrees in total in a pie chart, or 100% in a pie chart. So they already give you yard trimmings, other, paper and paperboard, glass, metals, and plastic. Then this little section here, which they call other, from that they showed you that other can be divided into rubber and leather, textiles, printer waste cartridges, food, and wood. So from this small little pie here, they made a whole new pie and told you what is the 11.2 made up of. So then you have a look and you see, oh, I have plastic, I have metal, I have glass, I have paper and paperboard, but I don't have yard trimmings. All right, so then you already think, I know that the pie chart is 100%, so I know what to do. So now we go and have a look at the questions that they actually present with the pie chart. So in your books it says, study the pie chart and answer the questions that follow. Write down one possible data collection method that was used to gather the above data. So how do you think? How do you think they collected the data? It is recycling. This is about recycling. So how could they do it? They could either ask people with a questionnaire. They can ask that. They could interview people, or they could do a survey. All right, go to schools, go to workplaces. So any of those things they could ask. That is a way in how they could collect recycling data. All right, then we move along to the next question. It says, calculate the percentage allocated for yard trimmings. Then you think, oh, well, I already studied it, so I think I know what I need to do. The pie chart is out of 100. I have all the other components, so I will be able to work out yard trimmings. So then to get to work out yard trimmings, I will say 100% minus. Why do I say 100% minus? Because the whole pie chart consists out of 100%. So I will take that and I will add up all the other components. So the 3.4%, the 11.2%, the 49.7%, the 3.3%, as well as the 9%. So I will then add them all up, and if I add all of those, I will get 76.6%. Then I minus it from 100. Why? The pie chart is 100% in the whole. It's 100%, and it's 23.4%, which is the missing component for yard trimmings. So then I have that. Then I know that this is 23.4%. If I add up all of those now, it will add up to 100%. So the next question, 2.2.3. The next question says, determine the percentage allocated for textiles. All right? So now we go and we have a look at our pie chart that was presented to us again. So this little part here is called other. All right? So other consists out of 11.2%. So then they tell us that other is consists out of wood 2.9, food 2.3, printer, waste cartridges 1.6, rubber and leather 1.7, and I see I have a missing textiles pie there. I have that missing. So in this question, they tell us that that is 11.2. That represents 11.2. So now I know that I must take 11.2% and I must add up everything in the small pie chart, so which is 1.6% plus 2.3 plus 2.9 plus 1.7. So I take all of that, I add it up, and I deduct it from 11.2%. I get added up, it is 8.5. Therefore, textiles will be 2.7%. That is then question 2.2.3. Then we move along to question 2.2.4. So question 2.2.4 says calculate in tons the total amount of plastic recycled in 2015. So calculate the total in tons, the total amount of plastic recycled in 2015. All right. Then right at the top of the pie chart, they said that the total recycling material for 2015 was 91.16 million tons. Okay, so they gave you the total. They want to know the amount of plastic that was recycled. So this small component over here, 3.4%, was allocated to plastic. So out of the total million tons, they want to know what was plastic. So plastic is 3.4% times the 91.16 million tons. So 91,160,000. That is 91 0.16 tons. So I then take on my calculator 3.4 divide by 100, multiply with that number. Or I can say 3.4 times that, divide by 100. It doesn't matter how you do it, you will arrive at an answer 3099440. This is the amount of tons in plastic, or that was recycled in plastic. All right, so that covers 2.2.4. Then, question 2.2.5. Give one possible example of a product that could be recycled under the metals category. Okay, so they want to know what can you put under this category, metals, which they call metals. What can give one product that we can recycle under that category? So it can be anything like cool drink cans, parts of a motor vehicle that you can recycle, household products that, or appliances that includes metal, anything like that. That will fall under the metals category. So that was question 2.2.5. If we then continue to question 2.2.6, state another type of graph that could be used to represent the data in the pie chart. So how can you, they want another method to represent the recycled material. So you can either represent or say in a bar graph, all right, where you then, for glass and paper boards, you will have bars. I suppose you can also use a stacked bar graph if you want to. But most probably, a bar graph would be a good way to also display the data of recycling. Then 2.2.7, determine as a decimal the probability of randomly selecting a material in the other category that is not textiles. Okay, so let's get to probability. Probability is a question that can appear in any category. Probability question can appear in finance. Probability question can also appear in data, like in this case. So the question that they've put to us is, determine as a decimal the probability of randomly selecting a material in the other category. Okay, so the other category, according to our pie chart, is the 11.2% category. All right? So we have 1.7, we have 1.6, we have 2.3, we have 2.9. So I just want to quickly show you the other category. So it's 1.7 plus 1.6 plus 2.3 plus 2.9. That adds up to 8.5%. So the other category is 11.2%. Why are we not including the textiles here? Because if you look at the small pie chart, they say that it's rubber and leather, wood, food, printer waste, and textiles. So why are we not including textiles? Because they said, determine as a decimal the probability of selecting a material in the other category that is not a textile. So that is why we're excluding textiles. So you will write 8.5 over 11.2. And then they specifically asked, the instructions said determine as a decimal. So then you will say 8.5 divide by 11.2, and you see that the answer is 0.758928 5. Then you present the answer in a decimal as they asked. So that concludes the questions on the pie charts then. Then we're going to move along. To the box and whisker plots. All right. So if we then move along to the box and whisker plot, they say the following. They say candidates sat for the National Senior Certificate Examination in November 2018. The box and whisker plot below show the 5-number summary of the average pass percentage for mathematical literacy. 5-number summary. All right, so if you don't know what a 5-number summary is, let's quickly run through what is a 5-number summary. So for you to be able to draw a box and whisker plot, you need a 5-number summary. So the 5-number summary consists out of the smallest number in the data set. It consists out of the largest number in the data set. It consists out of your Q1, your Q2, which is also your median, and it consists out of your Q3. Together, this is called the 5-number summary. So now the question that they ask, I just want to get to the questions. So the questions that they ask on the box and whisker plot is write down the pass percentage that's represent the following, the median. So here is our median. Our median is our Q2, all right, and it is exactly 69%. So 3.1.1a will be 69%. The next question, 3.1.1b, the question is quartile 3, all right? So here's my quartile 3, exactly on 80%. Then the next question is determine the difference between the highest and the lowest pass percentage, all right? The highest pass percentage and the lowest pass percentage. So in this case, it is the range. So it is 84 minus 64, and that is 20%. So grade 12s, they didn't ask this question in this specific question, but if we then need to work out the interquartile, like we explained earlier in the lesson, if we then going to work out the interquartile range, all right, then we're going to say the formula is Q3 minus Q1. They could ask you this. So Q3 is 80, Q1 is exactly 66. So 80 minus 66 is 14. Then your interquartile range will be 14 and your range is 20. All right, so this is the question on the box and whisker plot. Then we are going to move along to the last question in the set of notes that you received, and it is based on the following. It says the school-based assessment mark and percentages of the 10 lowest performing learners in mathematical literacy of a particular school is 260 in 2016 are represented in the table below. All right, so let's take a moment and consider the table that they present to us. So we have a column for the learner, the number of assessment tasks that they wrote throughout the course of the year, total marks that they obtained, and the actual SBA, school-based assessment percentage mark, and they say that the mark was rounded. Then they give you information about the SBA marks, Okay, the total mark for each task was 50. The actual SPCA mark is calculated of a maximum of 350 marks, and then the SPA percentage marks of candidates submitted valid reason if you don't write. Then we look at the questions that follow. So the first question says, determine the probability as a percentage of randomly selecting a learner in the table who wrote all the assessment tasks. Okay? So then we go, how many learners? We count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they gave the learners ABC so that you don't have the name of the learner. So we go to 4.1. So there's 10 learners in total. So determine the probability as a percentage of randomly selecting a learner in the table who wrote all the assessment tasks. Okay, so how many assessment tasks were there? And then you see that there's 3 learners out of the possible 10 who wrote all the assessment tasks. And we multiply this by 100. Why do we multiply it by 100? Because they specifically asked that the probability must be in a percentage, therefore 30%. All right, grade 12s, this is the end of our session for today. Sorry that we couldn't complete all the questions, but I'm quite sure you have the memo and you can ask your teacher or a fellow student if you don't understand. So I hope best of luck for the rest of the week and all the upcoming tests.